Unit 3, video number 7, recursive functions. In a recursive formula, each term is defined as a function of its preceding term. Each term is found by doing something to the term immediately in front of that term. The process of recursion can be thought of as climbing a ladder. To get to the third rung, you must step on the second rung. Each rung on the ladder depends upon stepping on the rung below it. So as you see here, a way that we can write this in algebraic terms is if I'm talking about the second value, then I need to take the first value and add whatever that step up is, okay? If I'm looking at the third value, the third term, I need to take the second term and add it to whatever the step up is. Okay, so I know this is a little different than stuff we've done in the past. And now for the algebra formula. If you are on the nth rung, okay, so this is a value you don't know, you must have stepped on the n-1 rung. So as you see here, a sub n equals a sub n-1, so you're going to find the one before it, plus the step up, whatever that is happening, the difference. All right, so I gave you this chart. Here's the given term. Here is the term in front of the given term. So here are just examples. So if the given term is a sub 4, the one that would go in front of it would be a sub 3. If the given term is a sub n, the one in front of it would be a sub n-1. And yes, you should write this chart in your notes. If the given term is a sub n plus 1, the one before it would be subtracted 1 for that, so it would be a sub n. A sub n plus 4, the one before it would be a sub n plus 3. Now in our function notation, if I'm talking about f of 6, the one before it would be f5. And if I'm talking about f of n, the one before it would be f of n-1. All right, so here's again another chart that you should put in your notes, because this is examples just so you can get the visual. And we are going to do something with this. So here's our term or our term number, which is our n values. Because this is the first term, would in this case be a 10. The second term would be 15. The third term in this sequence would be 20. The fourth term in this sequence would be 25. The fifth term in this sequence would be 30. The sixth term in this sequence would be 35. The n, we don't know because we're talking about the n. That's why we write formulas. So then just seeing it in subscript form, so you can see what that looks like, and then in what we call function notation form. All right, so to ask us write out the recursive formula for the table on the page before. So I wrote out the sequence here just so that we had this written, 10, 15, 20, 25, 30, 35. That was the actual terms. And to write the actual equation, remember this, a sub n is equal to a sub n-1 plus the step up. So we're looking to write this. So we know that a sub 1 is equal to 10 because my first term is 10. So you write that out. You'd put a semicolon and you'd say, okay, so a sub n is equal to a sub n-1 plus, well, what is the step up? What is going on each time? Well, if you notice, we're adding 5 each time to this, so it'd be plus 5. That is all you have to do for the recursive formula. It's just you have to write it in this formulaic form. Okay, so here we have a new table. We have our in column right here, 1, 2, 3, 4, 5, 6, and then n, doesn't really matter. And then we have our f of n, 3, 6, 12, 24, 48. Now, notice this sequence here is a little different because remember we've talked about this before. This is changing not by the same numeric amount by adding, but if you notice, this is changing by the same amount each time by multiplying. So to get here, I multiplied by 2. To get from here to here, I multiplied by 2. Same deal. Notice we're multiplying by 2 each time. Okay? So our formula is going to look a little different because of that. So if you think back to previous knowledge here, so we're still going to use the a sub 1. A sub 1 is equal to 3, semicolon. And then now a sub n is that formula 2 times a sub n-1. Okay? That's the formula that we're using here because, again, it's a geometric sequence, so we need to take that into account. So, again, you would write it, I'll write it down here, a sub 1 equals 3, semicolon, a sub n is equal to 2 times a sub n minus 1, because again, it's that times 2 that I need to take into account. Alrighty, so what you got to look here, we're looking in the y column, and we need to look at what's happening each time. Well, I noticed that there's plus 4 there, plus 4 there, plus 4 there, so I definitely have a linear situation here. Plus 4 there, so it is arithmetic, not geometric. So all I have to do, literally, is write, what is my a sub 1 term? Negative 5. Put my semicolon. This is more of a memorize this process type of deal than it is crazy hard. It is really just get the formula down. But if you notice, every single time, this stays the same. You're just figuring out what is the step up. In this case, the step up is 4. That is the recursive formula. This whole thing right here, you have to write for the recursive formula. And yes, you have to write your a sub 1 term, semicolon, and this. Okay, that's it. All right, I got one more example for you just to make sure we're good on this. So again, I started doing this. Okay, so I'm adding 10. I'm adding 10. I'm adding 10. I'm adding 10. See my pattern? And what I'm doing too is I'm finding that step up right away. So again, I write my a sub 1, in this case equals 5. And then I write a sub n is equal to a sub n minus 1 plus 10. That is it. That's all I have to do, but I have to get that formulaic process written down when I'm looking at the sequence.